So here now, our lesson today is talking about triangle congruence by SSS and SAS. Now, SSS, it's mean side, side, side. And SAS, it's mean side, angle, side. Now, in the previous lesson, we need the six statements congruence for the sides, for the three sides, and for the three angles to say that these two triangles are congruent. Here now, I can use three sides only, SSS, or two sides with an its angle also, to say that these two triangles are congruent without checking all of their six statements. Here, I need only, because all of these six statements are more information. Here, he told me that if you pick three sides only, and these three sides, or pick three statements only, talking about the sides, and these sides are congruent, I will say that my triangles are congruent. Let's start now with the first one. Here now, this start with my first postulate, and before that we will talk about what's the difference between postulate and theorem. Both of them are a statement. The postulate is a statement, but it's without a proof. I doesn't need to prove it. But the theorem, I need to prove it. The postulate, I can say it's accepted without proof. But the theorem, no, I need to prove it to say that it will be accepted, and I will name it as a theorem. Let's start now with my first postulate. Do you remember the first theorem that we are talking about it? What was the name of my first theorem? That will
Third
discuss
angle
later.
theorem.
Thank you. The third angle theorem. This will be my first theorem that we said that if we have two angles are congruent, the third one will be congruent too. This is a theorem. Here now we'll talk about a postulate. The postulate here, he told me that if you have two triangles, this will be my first triangle. And also here we have a second triangle. Okay, for these two triangles now, as you see, he told me now, if the three sides of all the triangles are congruent, what does it mean? If you have here A, B, C, D, E, F. Now, look at this one here. For this side, did you see it? That's, I move it now, A, B. If I say that this side is congruent to this side, okay, and also this side, which is BC, is congruent to EF, and this side, AC, is congruent to DF, if all the three sides, I told you, I'm saying now, are congruent, I will say that my triangle are congruent. Is it clear?
Yes, teacher. Teacher, does it differ if I said CA or AC?
If you say AC, you have to say DF. If you say FD, you have to say CA.
Okay.
Okay. So now here, I just need to write 3 sides. SSS, that means I need only 3 sides to talk about or to say that these two triangles are congruent by using 3 sides only. Side, side, side. If I prove that these 3 sides are congruent, I will say that the 2 triangles are congruent. Now, let's talk about problem number 1. Here, as you see, this will be an application of how we or why we use the math. Look at here. What did you say? What did you see? Sorry. You see a rectangle, as you see here, and this rectangle is like this. Okay, as you see in the here.
Yes.
And here you name it with P, N, M.
Teacher, how could we know if it is a postulate or not? To be proved.
Sorry? How did
How
you
can we know if? How can we know if it is postulate or not?
No, the postulate, that's I need to prove it. Look at here. After I say the postulate, did I told you let's prove it?
Teacher, you mean the postulate doesn't need to be proved?
Yes, it doesn't need to be proved. I say this is a postulate, this is accepted, let's apply it. Let's talk about it. But in the theorem, no. When I talk about this theorem, okay, I'll tell you now, let's prove it. If we see it's accepted, we will apply it. You will say it's okay. I will say later on that blah 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 according to the theorem because I approve it. But here without proving, without a proof, I will say it's accepted.
Okay.
Okay. Now listen here. Here we have in this problem, I want to use the SSS postulate. Now, he told me that given that line segment LM, where's LM? This one. He told me that LM is congruent to NP. And also LP is congruent to NM. Okay? I want you to prove that the triangle LMN is congruent to the triangle NPL. I want to prove that this triangle is congruent to this triangle. What did you say? Who can tell me?
Again, Miss?
Teacher, what is the question again?
Here, I told you, given that LM, the line segments LM is congruent to NP, and the line segment LP is congruent to NM. Okay? What I need to prove? I need to prove that these two triangles are congruent. So how can I start?
By the given.
By the angle.
Right now, there's no angles here. I'm talking about sides.
By the given.
By the given.
Oh, okay.
So I will
I
say
mean by the
the
side.
line segment LM is congruent to NP.
NP.
And also the line segment NP is congruent to NM. This is the first step. They are given. And what also? What about NL?
LN, they are reflexive.
They are reflexive. Thank you.
they are reflected.
So the line LN is congruent to LN. Why? Because of the reflexive property
of congruence.
of congruence. Thank you. So I prove that now. LM, where's LM? This one is congruent to NP. LP is congruent to NM. And I need now, he told me you have to prove 3 sides. I find only 2 sides. What about the third one? They are this one, which is LN. Now, since I prove the 3 sides are congruent, I will say that, the triangle LMN is congruent to the triangle
NPL. PL.
Okay, now look here. I told you that if you say LM, you have to say NP. But here, sorry, LM, you have to say PN. But here he said NP. Who can tell me why?
Because in the order NPL and LMN. And he's walking saying by the order of the triangle.
Did he work by the order?
Yes, here LMN and NPL.
Look here, if you start with the first triangle as it is,
Because teacher, if they were in the same side, it would be NPL instead of LNP. LPN.
look at the first triangle. Its name is
L.
L, M, and N. And the second one, if you would draw it as corresponding to it, you will name it with N, P, L. If you bring now, so I mean that if you want to draw it, okay, to cut it, to make corresponding, you will draw it like this. And then if you pick this one and you I need to move it, I don't know.
Yes, teacher, I mean that if I put it and corresponding to P attached to the
Yes,
triangle
here,
NPL.
imagine that this part here, I take it, I put it here and flip it to make it as this rectangle. Okay, so if you want to draw it as corresponding to each other, you will say that LM is corresponding to LP, MN, as you see here now. NM is corresponding to LP, and so on. Now, let's talk about this one here. Look at these 2 triangles now. Given that in this triangle, as you see, now he told me now that the B C F here and D here and BC is congruent to BF. So the line segment BC is congruent to BF and CD is congruent to FD. These are given. I want to prove that the triangle BCD is congruent to BFD. I want to prove now this. No. Oh, yeah, here. Okay. So I want you now to prove that this triangle, okay, which is BCD, is congruent to BFT. How? I said I need that 3 here. He told me about 2 sides. So I need how many sides extra? I need the third side. I'm saying here I have SSS. I have 2 sides. So I need to check where's my 3 side. Is it right? Where my third side?
It's BD.
It is BD. Thank you. So the line segment BD is congruent to BD. Why?
Reflexive property.
Because of the reflexive. So now I will say that these are also congruent. Now, did I prove that all the 3 sides are congruent?
Yes.
Girls, I need another one غير فرح. يعني talk with me, please.
Yes, yes. Yes, teacher.
So here I have 3 sides. Okay? I will repeat before that. Did you understand?
Yes.
Yes, teacher. Yes, teacher.
All the things that I
Yes,
said,
teacher.
understood?
Yes, miss. I don't understand very well.
Sorry?
I don't understand.
This Gafet?
Yeah.
Okay, I will repeat. Thank you for telling me. Here now we have this triangle. My first triangle is BCD, and my second one is BFD. Okay? For this one here now, I need now to prove that the triangle BCD, this triangle, is congruent to this triangle. By using the postulate SSS. SSS, that means side, side, side. So how many sides did I need? I need 3 sides. If I say that these 3 sides are congruent, I will say that my triangles are congruent. So how many sides did I need? I need 3 sides. The first one is given. He told me that the line segment BC is congruent to BF. This one and this one. And also, he told me that CD is congruent to FD. This one and this one. So how many sides now I have? I have 2 sides, but the postulate tell me that you need 3 sides. So from where I bring the third side? This one is proven, and this one also is proven. What about the third side here? How can I say it's congruent? Yes, Yara, can you tell me?
Yes, teacher.
Here, how can you say that BD is congruent to BD?
Because they are teacher, can I answer?
No, I want her to answer. How can you say that BD is congruent to
Teacher,
BD?
can I answer?
No, I want Yara.
Just a teacher.
Sorry?
Yes, teacher. Because they are congruent.
I want to say that they are congruent. How?
Sorry. Congruent. No. Corresponding.
Because of the reflexive property.
Miss,
Yes. Yes.
there is like the shapes have 5 letters.
5 letters here.
How? Yeah, 5 sides.
5 sides, pentagon. Okay. Okay. Continue your question.
Oh, okay. How we will solve it? The same type or
No.
there is different?
Here, no, this postulate only for triangles. I told you triangle congruence. In the first lesson, we are talking about all the shapes. Here, for the triangle only, for the triangle only, if you prove 3 sides are congruent, I will say that the triangles are congruent. But for the square, this postulate, it will not work. Okay? This postulate only for triangle. Thank you for
Okay, thank you, Miss.
Thank you for your question. This postulate is only for triangle. For square, for rectangle, for pentagon, hexagon, it will not accept. If I'm asking you about hexagon, you have to prove all the 12 statements that we talked about the previous lesson. But for the triangle, this postulate will work. So okay, so here now BD is what is.
Okay, thank you, Miss.
You are welcome. Now, so BD here is a reflexive property of congruence. It will be congruent. BD is congruent to the BD. So I prove now 3 sides. As you see, because I told you not, I need 3 sides. So now since I prove 3 sides, so my postulate SSS can work. So can I say now the triangle BCD is congruent to the triangle BFD?
Yes.
Yes.
Since that I prove 3 sides because of my postulate. I prove the first side and the second side and also the third side. I prove the 3 sides are congruent. So I will say that my first triangle are congruent to the second triangle.
Teacher, I have a question.
Yes.
In the problem, not do the concept, in the problem.
Hmm.
And teacher, when I when I flip the triangle of LMN to put it here beneath the triangle of NPL. So and because the side of MN because it is down, so it becomes MN.
Sorry, can you repeat? Because it's down?
Yes, yani when I flip it, the side of NM becomes MN because I flip it
Yes.
to the down.
Yes. So if you choose like this. PL, then this one, which is NL, NML, if you flip it, it will be MN. N, L. Okay, put it here. Here we have M, N, L. Okay, that's why you will say that L, M, L, M is to so you have to move it like this also. No, so it will be LM is to NP. So it have to be like this. Wait. NP. No. As I said, it have to be NPL, and the second triangle it has to be LMN with the same corresponding NP, NPL. So here LMN. This will be my triangles if either are corresponding. After that, I will say that LM is corresponding to NP, ML is corresponding to PL or LP to NM, and also LN to NL, that they are reflexive. Is it clear now?
Yes. So when I flip it, it becomes MN.
Yes, look here it is LMN. Here it will be flipping, so it will be drawing like this. If you need to check that if they are corresponding, don't think like that. Just draw these two triangles